Today we are going to talk about factoring a trinomial that has no coefficient in front of the x squared term. So it's going to have some number in front of the x term and some number for the constant. So for instance, we have, for example, 1 x squared plus 19x plus 60. There is no coefficient for the squared term, and theoretically, hang on, let me grab my pen. Theoretically, we have here x, whoops, I want my marker. We have, get rid of that, we have x squared plus bx plus c. So 19 represents b and 60 represents c. So there are going to be 3 steps that we're going to want to follow, and I'm going to write them off here to the side. So step 1, grab the wrong pen again. So step 1, you are going to factor c completely. Running out of room, so completely. Sorry, I had to cut that off. Then number 2, and I'll explain all this as I go through it, you will find the factors that add or subtract to give you b, the middle term. Squeeze that in there. And then 3, I'm running out of room. Let's see if I can somehow move this up. I think I can write below this and you'll be able to see it. I'll double check when I'm done. If not, you'll have to go based upon what I am telling you. All right, so then 3, you are going to put into a set of parentheses times a set of parentheses. You'll see what I mean by that in a minute. Essentially, we're going to factor this trinomial into a binomial times a binomial. So let's start off with step 1, factor c completely. Well, this is c right here. Technically, if you get in the habit of reading the trinomial backwards, it's telling you what to do. It wants you to factor 60, actually take the factors of 60 and add them, because there's a plus here, until you get the middle term of 19. If there were a minus here, we would be taking the factors of 60 and subtracting them to get 19. So it makes a difference what the sign of the constant is. It tells you whether you add the factors of that constant or subtract them. But I'm going to actually have you write out a table. So you're going to create a table. Grab the wrong pen again one of these days. Here's your table. And in this table, C is going to go here, and B is going to go here. And we also are going to be adding here and subtracting here. And so for our purposes today, our C is a positive 60, and our B is a positive 19. So if you don't know which factors add to give you 60, and factors, remember, are things that multiply to give you 60. If you don't know which factors of 60 add to give you a positive 19 right away, I always suggest that you start with 1 and the number. So that's what we're going to do. We are going to start with 1, whoop, did it again, 1 and 60. If you add 1 and 60, you get 61. That's not our middle term. If you subtract 1 and 60, you get 59. Still not our middle term. Don't pay attention to signs right now. We'll get the correct signs once we figure out which factors of 60 that we're going to use. The next number after 1 is 2. 2 does divide into 60 30 times. If you add 2 and 30, you get 32. And if you subtract 2 and 30, you get 28, neither of which are our middle term. The next number after 2 is 3. 3 also divides into 60 20 times. If you add 3 and 20, you get 23. If you subtract 3 and 20, you get 17. Again, neither of which are our middle terms, so we're going to keep going. The next number after 3 is 4. 4 does divide into 60 15 times. If you add 4 and 15, you get 19. And if you subtract 4 and 15, you get 11. So right here, we have finally found our middle term, 19. 19 matches that middle term. So the factors of 60 that add to give me 19 is 4 and 15. And notice that we are in the addition column. If this right here is a plus, you will be looking in the addition column. If this is a minus, you will be looking in the subtraction column. But for right now, until you get used to whether you're supposed to add or subtract, I just have you do both. So we choose these factors right here. And we have to figure out the signs. If we want 19 to be positive, so I'm going to put a plus right here by 19, we have to figure out the signs of 4 and 15. In order to add, because we're adding here 4 and 15 to get 19, they are both going to have to be the same sign. They both have to be positive in order to add to give me 19. If they're both negative, when you add two negatives, you add and keep the sign, you would end up having a negative 19, which is not what we want. If they are opposite signs, when you add integers with opposite signs, you subtract, which would put us in this column, and keep the sign of the larger. So we definitely want the same sign, and so therefore, in order for those to add up to give you the same sign, both 4 and 15 are going to need to be positive. And so essentially what we have done is we have broken 19x into a positive 4x and a positive 15x. Now there is a shortcut, and this is our shortcut. Normally from here we'd have to do some factor by grouping, but anytime there is no coefficient in front of the squared term, we can take our answer and drop it into parentheses. So here's our set of parentheses for our answer, and the first slot in each of these parentheses come from the factors of the first term in our trinomial. So x squared has to be broken up into two things. The only two things that will multiply to give you x squared would be x and x. So I am going to take x squared and break it down into x and x. Then for the last slot in each of these binomials, we get those numbers from the constant, which is our last term. So last slot, last term. First slot, first term. Whoops, first term. And then the middle term just falls into place, as I'll show you when we remultiply to check. So we've already figured out that positive 4 and positive 15 are the factors of 60 that belong here. Because there's no coefficient in front of the squared term, we can just take directly from the table and plop them right here into our, oops, I'm on the wrong one. So we can plot them right here into our parentheses. So here they go. And then this is our final answer from right around here. I'm going to put a box around it, and I'm going to prove to you that this is indeed our final answer. So you can either double distribute or use the box method, but if you take x and multiply it to x, you get x squared. If you take x and multiply it to 15, you get a positive 15x, which we see in our table. That's one of the numbers we chose. Then we're going to take and distribute the 4. So 4 times x is a positive 4x, which is a like term to the 15x, so they would line up. And then 4 times 15 is a positive 60, which has no like term, so it is not going to line up to anything. And if you add straight down, you get x squared plus 19x plus 60, which is indeed exactly what we started with. So you can always check your answer to see if you're correct. Now the rest of these should go pretty quickly because we shouldn't have to talk so much through it. So let's look at example 2. All right, so with example 2, we are going to start off with our table. And so I'm going to do the table over here. And remember, in our table, C is going here on the left, so it might behoove you, which means to benefit you, to actually title these columns with what goes in there. And then I'm also going to add and subtract in this column. So I am looking for, if you read this backwards, the factors of 8 that add to give me positive 6. So my C is a positive 8, so it's going to go here on the left. And my B is equal to positive 6, so that is what I will be looking for. So let's start with 1 and 8. If I add those, I get 9. And if I subtract them, I get 7. Those are not my middle terms. So moving on to 2 does divide into 8 4 times. If I add those, I get 6. There's that middle term right there. I can actually stop. So I want 6 to be positive. If I can get my plus in there. So I want my 6 to be positive. Note that, remember I said we were taking the factors of 8 and adding. Notice how we ended up in the addition column. So that's exactly where I wanted to be. In fact, let me circle this because those are what I want. And I've got to figure out same sign or different signs. So if you're going to end up adding numbers, same sign, add, and keep. So they have to have, your two numbers have to have the same sign if you're in the addition column. So they're either both positive or both negative. The only way to add 2 and 4 and get a positive 6 is if they are both positive. So since we do not have a coefficient from the squared term, we can actually use a shortcut at this point. And our shortcut is going to be to just put our answers directly into our binomials. Okay, so the x squared gets split. It's the first term in the trinomial, so it gets split in the first term in the binomials. And then you're going to take directly from your chart your plus 2 and your plus 4. And we are done. And again, if you remultiply, x times x is the x squared. X times 4 is 4x. Distribute the 2. 2 times x is 2x. The 2x and the 4x are going to add to give you 6x. And 2 times 4 is 8. Okay, so that should finish that, and we are moving on to the next problem. Example 3. So once again, if you read this backwards, you should kind of have an idea ahead of time of where you're going. We're going to find the factors of 6 that add to give you 5. So let's get our table started. So remember, our C goes here, our B goes here, and we are going to be adding here and subtracting here. Now our C is the positive 6, and our B is positive 5. So we're, again, looking for the factors of 6 that add to give us 5. So I already feel, or should know, that I should be getting my answer out of this addition column because C is positive. Now this is a bit of a tricky problem because 5 is going to appear twice. It's going to appear in the addition column, and it's going to appear in the subtraction column. So I'm going to do all the factors of 6 so you see what I'm talking about. So 1 times 6 is 6. If you add those, you get 7. And if you subtract those, you get 5. So here's your first 5 that shows up. It's not the right one, which I'll show you why in a minute. Then the only other factors of 6 would be 2 times 3. And look, if you add those, you also get a 5. And if you subtract them, you get a 1. So let's explore why the first 5 is not the one we're looking for. So remember, we want a positive 5. So if we choose this first 5, the only way to make this 5 positive when we're subtracting is for these two numbers to subtract. Remember your integer rules. Different signs subtract. Keep the sign of the larger number, then you'll be exact. So in order to subtract these, they have to have opposite signs. One's going to have to be a positive and one's going to have to be a negative. Well, because 6 is the bigger number, it's going to carry the sign, and we want 5 to be positive. So 6 will actually end up being positive, and then the 1 would be negative. And so now if you add these two together, you do indeed get a positive 5 because you're going to subtract and keep the sign of the larger. However, remember that these are multiplying to give you C. If you take a negative and multiply it to a positive, it gives you a negative, not a positive. So that's why this particular one, I'm going to put an X through, because this is not going to give us the correct answer. Instead, we're going to use these. We still want 5 to be positive, but if we are going to take the numbers 2 and 3, our only choice is to add them to get to 5. In order for them to add, they have to be the same number or the same sign. So in order to get a positive, they're both going to have to be a positive. So now if you add 2 and 3, you do indeed get a positive 5. And if you multiply a positive times a positive, you do indeed get a positive. So this is why we have chosen the correct 5, and we have the correct signs. So now when we put this in our parentheses, we're going to take the x squared, and it gets put in the first slot and gets split up as x and x. And then directly from the table, you've got a plus 2 and a plus 3. And this is our final answer. I am going to multiply to prove to you that it works. So x times x is our x squared. X times 3 is 3x. Distribute your 2. 2 times x is 2x. A 2x and a 3x do add to give you 5x. And finally, 2 times 3 is a positive 6. Next example. Example 4. So this time we do have a negative b, but we still have a positive c. So if we read it backwards, so we have an idea again of where we're going, we're going to take the factors of 16 and add them again until we get negative 10. So let's go ahead and mark up our table or get it set up. I'm going to label it C, B, and put in my plus minus because I'm going to add and subtract. Well, my C is a positive 16. So because it's a positive 16, I know that my value that I'm looking for my middle term should end up in this addition column. And then my B is negative 10. Whoops. And here we go. So the first factors of 16 are 1 and 16. If I add those, I get 17. If I subtract those, I get 15, not 10. So keep going. My next number after 1 is 2. 2 goes into 16 8 times. If I add those, I get 10, and boop, there it is. 10 is in my addition column as I already determined it should be. So I'm going to stop there. So these are the ones that I'm looking for. My sign for 10 should be negative. So in order for me to get 2 and 8 to become 10, we're going to have to add them together. And if I'm adding, I have to have the same sign. Because my sign's negative, I know that both of these will end up being negative. So because there's no coefficient in front of my x squared term, I know that I can use the shortcut, which is going directly to my parentheses. So the x squared is going to get split as x and x. And by the way, your variable might not always be x. It could be b, so this would be b and b if this is b squared. It could be d as in dog, so this would be d squared, and that would be d and d. So just adjust as necessary. All right, so let's go take directly from the table, -2 and -8. And that is our final answer. Let's multiply just to double check. So x times x is x squared. X times -8 is your -8x. -2 times x is -2x. So a -2x and a -8x do add to give you -10x. A negative times a negative is a positive, and 2 times 8 is 16. There works. Example 5 coming up. So this time in example 5, we actually for the first time have a -c. So if you read it backwards, we're going to take the factors of 18 and subtract them to get a +7. So I should be looking for my factors of 18 in the subtraction column, not the addition column. So let's set up our table. Oops, I don't want that color. Okay, let's try it again. Here's my table. Let's label it C and B and put our plus minus. So C is a -18 and our B is a +7. Okay, so the first factors of 18 are 1 and 18, and if you add them you get 19, and if you subtract them you get 17. Neither of which are my middle term, so the next factors of 18 are 2 and 9. If you add them, you get 11, and if you subtract them, you get 7. Well, there is my middle term, and it is in the subtraction column where I thought it would be. So I'm going to use this along with these two. So the sign I'm looking for 7 is a plus. So I'm going to put a plus, see if you can read that over that. So there's my +7. And if I am in the subtraction column, the only way that I can subtract two integers is if they have opposite signs. So one of these needs to be positive and one needs to be negative. Remember, when we subtract integers, you subtract and keep the sign of the larger. So the larger number is going to carry the sign that you want. Since we want a positive and 9 is the larger of the two numbers, that's why 9 is going to get the plus sign and 2 will get the negative sign. So now I've got two numbers with opposite signs. I will indeed subtract. That gives me 7 and keep the sign of the larger, which would be positive, and that's exactly what I want. So now that we have no coefficient from the squared term, we can use our shortcut by putting this directly into parentheses. So again, the x squared gets split into x and x. And then directly from the table, we'll have a -2 and a +9. And then this is our final answer. And so again, I'm going to prove to you that this does work. So here's x times x. There's our x squared. Then x times +9 is going to give us a +9x. I'm going to write this one out for you. And then -2 times x is going to give us a -2x. And so when we add those numbers with opposite signs, you subtract, keep the sign of the larger, you do indeed get a +7x, which is what we're looking for. And finally, the negative times the positive gives us a negative, and 2 times 9 gives you 18. So it did work. Now for our last example. In example 6, Again, read it backwards. We're going to take the factors of 24 and subtract them to get a -5. So I'm looking for my middle term to be in the subtraction column. So let's set up our table and then label it C and B, plus and minus. My C is -24 and my B is a -5. So because C is negative, I know I'm going to be looking in this column for my middle term of 5, which we're going to make -5. So our first factors of 24 are 1 and 24. Add them, you get 25. Subtract them, you get 23. Not my middle term, so let's move on to our next factors. After 1 is 2. 2 divides into 24 12 times. Add them, you get 14. Subtract them, you get 10. Still not my middle term, so the next number after 2 is 3. 3 divides into 24 8 times. Add 3 and 8, you get 11. Subtract 3 and 8, and you get 5, and bingo, that's what I'm looking for. Notice it's in my subtraction column, and I'm going to make it a -5. So this is my middle term, and these are the factors that got me there. So my middle term is negative, so I'm going to put a negative. There's a little wavy negative in there. And remember, for two numbers to get 3 and 8 to become 5, we're going to have to subtract them. And in order to subtract two numbers, they better have opposite signs. And the larger of these two, which is 8, is going to carry the sign that we want. And remember, we want a negative. So I'm going to put a negative by that 8. So the 8 gets a negative. That means the 3 is going to get a positive. And finally, we have no coefficient for the squared term, so we are jumping to our shortcut, which is to just put our answer directly into parentheses. The x squared gets split into x and x, and directly from the table, plus 3 minus 8, make that minus a little bigger, and then this should be our correct answer. I am going to multiply it to double check. So x times x is x squared. X times -8 is going to give us a -8x. And then distribute the 3. 3 times x is going to give us a positive 3x. So if I add those, a negative and a positive, we subtract. That gives us 5x, and keep the sign of the larger. Well, the larger is 8, so that's negative. So that -5x matches up with that. And finally, a positive times a negative is a negative. 3 times 8 is 24. And that's it. So go ahead and complete your homework and come ask questions if you're stuck. Have a good day.